I'm back with another exciting video, and sorry for taking so long. I just got busy with my life. In the last 2 years, I just couldn't make a video. So, yeah. Okay, so today I have you must have seen right from the title of this video that we would be solving permutations question. So, this is actually a very common question asked in many interviews. Like you can find multiple solutions for this also online. But today I'm going to teach you how to simplify and think for any recursion problems. Like the thought process behind it and how you can go to the solution, how you can approach to it. That is what we are going to discuss today. Okay, so let's read the question first. Given an array nums of distinct integers, return all the possible permutations and you can return the answer in any order, right? And the constraints, you can see that the nums length is going to be maximum of size 6 and the nums values, they are going to be between minus 10 to 10, and all of them are unique, so we don't have to explore the variety where there are duplicates present in it. So yeah, for now all the numbers are unique. It's a very basic permutations question. Okay, so how exactly do we perform a permutation? uh, Normally what we do is, okay, so let's just take this example only, 1 2 3, right? These are our set of numbers and we need to form a permutation with these. So let's take three blanks. This is going to be our result. Uh, the final permutation that we can form with this. Um, from this we can see that for a permutation to be to form a permutation, we'll take one number each at a time and fill this first blank with this. So it goes like, first we try to take one and form all the permutations possible with this, and then we take two, and later we take three. Okay, so if we choose one, we are like cancelling this out. That means we can't use this one again. We proceed to the next index, and in this next index we have two choices to make. Either this can be a 2 or a 3. Two choices, this or this. Okay, so if we take a 2, this get cancelled out and we are left just with 3. Okay, and if we take a 3, the 3 gets cancelled out and we would be left with 2, right? This gives us two permutations if we start it out with 1. Similarly, same thing goes for 2 and 3. 2, we have two choices. It can be either 1 or 3, the next index basically, right? And then from here, since 1 and 2 are already used up, we'll go with 3 here in the next index, and here we would be using 1. Okay, this also gives us two permutations. And similarly, if we start it out with 3, we have 2 or we have 1. And if we take a 2, we have 1 that we can use in our very last index. And if we take a 1, here we would be having a 2. So this is how we perform our permutation. So to simplify this, what we do in a permutation is that we take a particular index, we fill that out with as many possible values that are available from our number set, and then we proceed to the next index. Here we make sure that this particular number that we have already visited is not used up again in the future. Okay, so same steps we are going to perform for each and every index. And when does this exactly stop? Once we reach the last index, we are done with it. We can just return from here. We can push this particular permutation once we have reached the last index into our ultimate result set, and then it's done. So now the same thing, we just need to code it out. Okay, so how do we do this? So for permutations, we found that we need to maintain something like a tracker to check if your particular number is visited or not. We'll maintain that using the visited vector. This is of type bool. Let's mark this as false initially. And then we need to have a ultimate result vector, which is going to be of this type. So I'll just copy it from here. And we should also have a temp vector. This temp is like it maintains the that particular permutation, that you are performing right now. Now let's have a helper function here. This is going to be my recursive function. So for any recursive functions, to solve any recursive problems, the simple funda is that you just need to figure out how you can convert your sentences, how you can translate what you're doing into this code, right? And how you can uh, simplify it by calling the same function again, that you need to have a track of, and what variables are exactly changing with every recursive call, that you need to maintain a track of. So for now, what I'll be pushing in is my nums array, my visited vector, temp, and result, and my current index, which I'll be starting out is 0. So that I'll be passing in, and then I'll return my result vector. And then while writing the actual implementation of this function, here goes my nums array, nums vector, my visited vector, temp, result, and index. Index. Okay, so what we thought, for every index, okay, for this particular index, we'll take every number that is available to us, that means it's not visited previously. Nums dot size, here I'm taking every number for this particular index, and I'm checking if it's already visited or not. If it's not visited, only then I'll be proceeding, or else I'll just go to the next iteration. And first thing is that I'll make this as true, since I have visited just now, and I'll push this particular nums, this value that I'm currently holding, into my temp vector, stating that I have filled in my index with this particular number. and then I'll call my helper function again. But this time, since I have my index, this particular index filled with this number, I'll move on to my next index plus 1, and then I'll pop out after everything finishes. Why do I need to pop out after I finish this particular permutation? I just need to reset my temp, and to reset this I'll just be popping out the last number that I have pushed in, and I'll make it as false also, so that it can go with I mean, while performing the next iterations, it can go with the same temp and same visited array. And when do I stop? What did we decide for this? If my index becomes greater than or equal to my nums array size, that is when I'll push my temp into my ultimate result vector, and then I'll back out. That means I'll return from here. Okay. What exactly is wrong with this? Okay. I'll try to submit this. So, what would be the time complexity of this? It's going to be n into n factorial. Why is that? That means n factorial is the number of permutations that you have right now. I mean, that you generate with this, and n is it gives the number of paths actually. Um, for what exactly are we doing here? For every number, I mean, in every present in every index, we are forming a permutation, right? That means for the next index we'll be having n minus 1 choices, and then for after that we have n minus 2 choices. That is we how we get n factorial, and this happens for every number in that index, n into n factorial. So that's how we get our complexity. Okay, so um, I'll be signing off right now. If you really like my video, please like, share, and subscribe to it. Please, if you find it really helpful, just share it with anyone who is studying in college, or who is in dire need of uh, uh, while practicing DSA if they need it. Yeah. Thank you. Thank you so much.